Good afternoon, everyone. This is Lynn Katz-Cherry with the Great Lakes Green Chemistry Network and Clinton Boyd with the Michigan Green Chemistry Network. Green Chemistry Clearinghouse. And we're very happy to welcome you to our webinar today, Alternative Assessment and Risk Reduction Guide, presented by Alex Stone, who is the Senior Chemist for Safer Chemicals Alternatives, the Washington Department of Ecology, and he's also with the Hazardous Waste and Toxics Reduction Headquarters. Before we begin, I just want to remind you that to check out our website for the Great Lakes Green Chemistry Network, www.glgc.org, where you will find the schedule for the upcoming webinars. We have some great ones coming up in March with Dennis McGavis from Goodyear Tire and Rubber. In April, we have Mike Velivo talking about chemicals policy, and in May, we have Mark Rossi talking about the BIS NGO new guidance on for companies on finding safer alternatives. Well, we're really lucky to have Alex today. He's very busy. He graciously agreed to give us this hour of his time to talk about this wonderful new guidance that he has been working on with 8 member states of the Interstate Chemicals Clearinghouse. And they've been working for the last 20 months on a guidance to reduce risks to human health and the environment by replacing toxic chemicals with safer alternatives. So he's going to tell us about that today and direct you to where you can see the draft version of it and where you'll be able to obtain the final version of it. Alex is a senior chemist at the Washington State Department of Ecology, where he's worked for the past 20 years. He currently functions as a safer chemical alternatives chemist for the Hazardous Waste and Toxics Reduction Program. He has been selected as the chair by members of the Association of the 8 states working together on the Alternative Assessment Guide document, and is Ecology's representative to the Toxics in Packaging Clearinghouse. He works on a number of chemistry-related projects, including Washington's Chemical Action Plans, Safer Chemical Alternative Assessments, and the Children's Safe Product Act. He also acts as an advisor to the ecology management on chemical policy and chemical-related issues. And I've heard him speak before, and he's terrific, so I'm going to turn it over to you now, Alex. Thank you.
Very good. Thank you very much for the invitation to chat. I'm always happy to talk about these things, and I appreciate the opportunity. Actually, I do have hot news off the presses that I'll get to you a little bit later. We had a meeting of the guidance team this morning and made the decision to release the draft guidance document for a 45-day formal comment period. So I hope to have that up and running maybe as early as next week. But more on that later. If you are interested, and as Lynn mentioned, we do have a lot of information on the guidance, so I'm going to probably go through things rather quickly, and I apologize for that, but I probably have too much information for the 45 minutes or so that I have, and I tend to talk too much anyway. So, but I do want to leave time for questions and input and any information you might have to help us out with this process. So I apologize for that, but you can go on, and some of the links that Clinton mentioned later has links to other talks that I've given on the guidance, and you can go into it in more excruciating detail if you're interested. To give you a little bit of an idea of the content, we're going to talk about, what is an alternative assessment, who is working on it, who's funding it, why alternative assessments. I'm going to give you a little bit of information on what we've come up with as a guidance team in terms of fundamentals, our golden rule and principles, and then a little bit of information about the alternative assessment guidance document itself. Details on some of the modules, not all of them, because that could be another hour if I went into excruciating detail. Timeline, stakeholder involvement, and then leave time for questions, as I mentioned. So to give you an idea on the background, we received $150,000 from EPA to fund the alternative assessment guidance document. Most of that funding has been used to hire contractors to help with the process. As Lynn mentioned, there are 8 member states of the Interstate Chemicals Clearinghouse. I always exaggerated, and for some reason I call it the International Chemicals Clearinghouse, Delusions of Grandeur. Anyway, the Interstate Chemicals Clearinghouse, 8 members have been working together. Our first meeting was in August of 2011, and we hope to have this done by June of this year. So it's pretty much been nearly a 2-year process between conception and finalization. We did hire contractors for technical and stakeholder support, and then for technical writing assistance as well. As I mentioned, most of the money has gone to contractors. EPA's Design for the Environment program was very good at providing technical support as well. And since EPA has been doing a lot of work on alternative assessments over the last almost 20 years or so now, they've got a lot of technical expertise that was very advantageous to us. So what was our mission statement? That was one of the first things we worked on. We wanted to create an alternative assessment process that promotes continuous improvement, so that we wanted to, basically find ways of eliminating toxic chemicals and replacing them with safer alternatives, with the ultimate goal perhaps of having products that are pretty much benign by design. So it works very much into the green chemistry process. And the way I sort of phrase it, and I don't know if people are more knowledgeable about green chemistry than I are, green chemistry is what you do when you start developing a new chemical or product or process or whatever. But alternatives assessment is what we do when we have existing products that we're trying to improve while green chemistry gets up and running, if you will, or gets more commonly involved in the manufacturing process. So that's what we're doing with alternative assessments. We're trying to meet some of the goals, green chemistry goals, but dealing with existing products and processes. So our goals and objectives, we wanted to find a document that reduces risk, and I think that's a very important concept that I'll go into more detail later. We do use risk in our alternative assessment, but our objective is not to assess risk, which is what you get with a risk assessment, but our objective is to reduce risk, and we do this by replacing toxic chemicals in products with inherently safer alternatives. And I'll go in a little bit more about that process in a subsequent slide. We want to prevent uninformed or regrettable substitutions, and there have been plenty of documented cases where companies have stopped using a chemical of concern and then replaced it with a chemical that was equal or even sometimes greater concern. And there are some issues in front of the Washington State Legislature right now that show that 5 years or so ago, Washington State banned pentabromo diphenyl ether as a flame retardant in all applications. Some manufacturers went out and replaced it with chlorinated phosphate flame retardants, which have subsequently been shown to be very problematic as well. So now there's a bill in front of our legislature to ban those chemicals. So we're trying to get off the toxic treadmill of just, I call it the whack-a-mole, where a chemical that's a problem pops up and you ban it or you whack it back down, and it gets replaced by another chemical that's an equal problem and you whack it down. And to get out of that sort of whack-a-mole treadmill, if you will, and get a process that actually gets people to start thinking about, okay, yes, I can use decabromo diphenyl ethane as a replacement for the flame retardant decabromo diphenyl ether, but is it wise to replace a chemical that's likely to be persistent, bioaccumulative, or at least some of its degradation products, not necessarily it itself, and toxic, with another PBT? So trying to get off that treadmill. We wanted to define information that indicates what we think is an credible alternative assessment, and we want to, institute a process of continual improvement. It would be nice if we could find, if we're dealing with a toxic chemical, and we could find a chemical that is green right off the bat. And that's unlikely to happen, though, because it will take time for the green chemistry process and principles to get implemented where we actually start getting chemicals. And I'm sure there are chemicals out there now that meet those criteria as well. But at least if we can start an incremental process where we move towards that goal, I think that was one important goal for this group as well. So here is our alternative assessments golden rule. And I think this is very important to our process because the objective of an alternative assessment is to replace chemicals of concern with inherently safer alternatives, and we want to protect and enhance human life and the environment. And there are certain principles that we think are in support of that golden rule. And I've sort of just listed the titles there. At the end of the presentation, I'll give you links where you can go and find out more details about all of this information. So we have, paragraphs explaining each one of the principles in more detail. But you can see that, not only do we want to reduce risk by reducing hazard, we also want it to be transparent, and we think that's very important. We want to understand the decisions that people are making. We may not always agree with those decisions, but I think understanding is an important step forward. Flexibility, we want people to think about things over the full life cycle of the product and not do necessarily a full life cycle analysis, because I think that's a very complicated and still developing process, but at least start thinking about its life cycle impacts. Green chemistry, of course, and continual improvement I've mentioned before, and also to consider uncertainties, because no decision that we make is ever going to be perfect. There's always going to be uncertainties involved in it. So one very important concept in what we're trying to do too is the realization that if a safer alternative exists for a toxic chemical that does the function that chemical is required in the product, and it does so at a cost-effective price, there is no justification for continued use of that toxic chemical. And I think that gets back to the argument about, well, there is no exposure, therefore we can continue to use toxic chemicals. We're not really interested in that argument anymore. We're more interested in the identify safer alternatives so we can reduce risks, not assess risk, because I think we've seen over time that there's been lots of problems with figuring out exposure and encompassing all of the possible avenues of exposure, which has led to some problems in release of chemicals and the problems that we now face with trying to clean up and deal with toxic chemicals in the environment. Now, some of the points that are coming in the next bullet are money saved by not using toxic chemicals, and these are bullets that I've collected through several discussions with industry who have been looking at these issues and have started implementing the alternative assessment process. They can save money by not having to manufacture, transport, and dealing with potential spills of toxic chemicals. They don't have to worry about potential legal issues about impacts from use and end of life, being sued by consumers that are concerned about potential impacts. Clean up contaminated sites, and that's something that's very important for Washington State, is that we spend hundreds of millions of dollars every year cleaning up sites that have been contaminated with toxic chemicals. If we can eliminate the use of toxic chemicals, then 30 years down the road, we won't have those contaminated sites that we have to deal with. There's also the regulatory cost of managing both chemicals and toxic waste. And for these reasons, several major U.S. and international companies require alternative assessments and have sort of started requiring it of their suppliers as well. So that quite often I get calls from companies that saying, I'm a supplier to company X and they want me to tell them what hazards are associated with the chemicals that I'm using. What are they talking about? So I have to talk to them about the alternative assessment process and what they're looking for. But I think that's becoming more and more broadly used, which I think is a hopeful sign and a positive sign. So to give you some idea on the fundamentals, here are the alternative assessment components. So we broke them down into 4 scoping modules, which sort of defines how you're going to do things, and then 7 assessment modules, which are components that we think are important to consider for inclusion in an alternative assessment. So this is a little bit of change from perhaps some of the previous presentations I've made, this sort of breakdown into these different areas. I do want to make a point, though, that it's not expected that all alternative assessments will include all of these modules. Think of it as a little bit of a buffet where you get to some extent pick and choose which ones you use. It's important, though, to remember you have to choose the ones that support the objectives of an alternative assessment. And in the guidance, we do have very clear recommendations on what modules you should be using in an alternative assessment. And I use the term recommendation because this guidance is primarily, for 7 out of the 8 states, it's to be used in a voluntary basis, because 7 out of the 8 states have no authority to require an alternative assessment. California is the only state that has that authority, so they can make a requirement, but all the other states can only make recommendations. But we think the recommendations we've made are very supportive of the goals of an alternative assessment. Excuse me. So our guidance approach, and this is where I think this is fundamental to everything that we do, it's based on a risk reduction approach. And I'm sure you're familiar with the equation where risk is a function of hazard and exposure. So what we mean by risk reduction is basically a two-step process where you identify the chemicals with the lowest possible hazard. And again, remember that we're wanting the chemicals that perform and cost and effective. So we're not looking solely at hazard, but it's very important to find the one that has the lowest hazard that meets these other requirements, but that also you evaluate the exposure of those and you identify the optimized chemical, if you will, the one that has both the lowest hazard and the lowest exposure. So use of an exposure evaluation alone as a rationale for continued use of a toxic chemical is not something that's really supportive of the goals of an alternative assessment. So quite often we've got a number of individuals that come to us and tell us that they are doing alternative assessments, but when you really look into the details, what they're doing is a risk assessment, not an alternative assessment. So they're using quite often exposure to justify the continued use of toxic chemicals. And I've looked at a lot of risk assessments over my years, and there's quite often a lot of concerns I have with them. They quite often only look at exposure during use and doesn't include the full life cycle. So quite often I'll see a risk assessment that says, okay, my product contains this toxic chemical, but my product does not cause any exposure concerns. So there's no risk through exposure of the use of my product. But what they don't quite often consider is that there may be hundreds of products that use that chemical and that the exposure from your product is not the only exposure. So there are those concerns. They don't quite often adequately consider costs because they don't consider long-term management, cleanup, and disposal costs. They're often externalized, and we as a society end up having to pay those costs. They're often difficult and expensive to implement, so they're not often used by small businesses. And that's another bullet that I've actually pulled from conversations with companies. That's not my perspective. That's what I've been told by companies that I've been dealing with. And then one thing that's very important to a number of companies as well is that they cannot control exposure. They can make assumptions about how a chemical or a product can be used. They can provide guidance how they think a product can be used. But quite often, products will end up being used and exposures will happen that are completely unexpected. So they cannot control exposure, but what they can control, or at least have some direct input, is how hazardous the chemicals are in their product. So that's why a lot of companies have sort of bought into the alternative assessment process, because they can assess hazards, and that's something they can control. And the exposure issue that I quite often use is the laundry packs, where the single-use laundry packs that have become pretty much or much more common lately. A lot of risk assessments have been done of them and evaluated potential exposures, but I have yet to see one that included the issue that kids might think of them as a juice pack and would start drinking them. And there have been plenty of documented cases where that has happened. So that's an example of where exposures will happen that are completely unexpected. And I do want to point out, and the reason for this slide is to show that these are not just concerns that have been raised by the states. The National Academy of Science recently released a green book on sustainability, and in there they said basically that better methods beyond risk analysis are needed to support consideration of health and environmental effects for the green chemistry goal of safer products and more sustainable chemical usage. So, this is the National Academy of Science saying pretty much the same thing, and we're thinking of alternative assessments as one of these new tools that meets the finding 4.6 from the NAS. We also do want to comment that, at least in Washington and a number of other states, we're seeing a lot of concerns about children's disease and an increase in incidence of childhood disease and birth defects, and how they're continuing to increase. So that's something, and I'm not saying that chemicals are necessarily the cause or the single cause for any of that. It's very difficult to correlate between a particular chemical and a particular disease factor. But chemical usage is something that we can do something about, and maybe it would help decrease some of these incidences of childhood birth defects or diseases if we were more careful about the hazards, the chemicals that we are dealing with. I do have a couple of slides here that I've stolen from Hewlett-Packard in presentations that they've made. So CHA is an abbreviation for a chemical hazard assessment. So that's just the hazard portion of an alternative assessment. But they find it's faster and easier to complete. It's narrow. It's very well defined. It provides very well defined endpoints that they can collect data and then very clearly identify whether or not for that particular hazard trait, for that particular carcinogenicity or reproductive toxicity or one of those endpoints, that your chemical has a high, medium, or low level of concern. It's science-based, and it facilitates relatively quick assessments. And it's increasingly used by regulatory bodies. And I mentioned that California now has been given legal authority to require alternative assessments, and it's also part of the European Union REACH legislation. They have guidance on alternative assessment as well. So it aligns well with business regulatory processes, and it's useful as an indicator too of where maybe people are going in terms of regulation. And at least, I'm trying to think of a better way of saying this, but I think a lot of companies like Hewlett-Packard are looking at getting ahead of regulations. They don't want to be in a responsive mode, they want to be in a proactive mode. And I think that's one of the advantages of an alternative assessment. It lets them get ahead of the curve, if you will. And this is their concerns about risk assessment. It's overwhelming to many of their decision makers who, they're not engineers, they're not procurement engineers, they're not always careful or used to dealing with that level of detail, and they're overwhelmed by the information that's out there that they need to review and reflect and reach a decision on. And they can't really effectively incorporate that information into their existing procurement processes. And one thing that they have concerns about risk assessments, they're not comparative. They're not in a useful format that you can compare decisions, where a lot of the alternative assessments, and particularly the hazard assessment, you can line chemicals up in one table and use color coding and make it very clear what your results are and which ones pop out as a problem and which ones pop out as potentially being okay. This is just a quick quote from some of the documentation from Hewlett-Packard. It's their Global Citizens Report, and in here they talk about the green screen, a hazard-based assessment framework that they use extensively for part of their alternative assessment processes. So I won't go over all the wording, but you see that they have included it in their documentation, their corporate plans as well. So to give you, we'll move on now to a little bit more information about the guidance structure. I did talk about the modules, and I'm not going to go in excruciating detail, but I'll give you a few highlights from a few of them. So here are the scoping modules, the 4 of them that sort of help you define how you're going to do an alternative assessment. The initial evaluation module is an example, and it's one that you need to do in all alternative assessments. It asks whether or not you need to do an alternative assessment at all. Is there some other step that you can do? Can you just eliminate the chemical of concern? And one of the issues that, one example that I have about that is that there's a fairly well-known major sports gear manufacturer who had a number of toxic metals in some of his plastic formulations, and they went out and investigated why those metals were in the formulation, and they found out 3 out of the 4, I think that was either 3 out of 4 or 4 out of the 5, were just an artifact from older types of plastic, and they served no useful function in the current plastic. So they were able to eliminate those 3 or 4 metals and had no impact on the final product at all. So sometimes, chemicals get pulled along for the ride just because historically they were used and they don't really fulfill a function. So by doing that, we get the companies to ask, what is the function that the chemical does? Can you do it? And I've had other examples of companies that have created products using chemical flame retardants, and then they've investigated and found out there are ways of doing creating the product without using chemicals at all, so that they've been able to manufacture them without the use of flame retardants. If you can eliminate the use of the toxic chemical, then you don't have to worry about doing an alternative assessment. You can just remove it, declare victory, and move on. But if you can't do that, then you do need to proceed with an alternative assessment. And we have pages of questions that sort of are used to help guide the individuals through these processes, and questions that we think that they should be posing to themselves and collecting data to answer to help them reach conclusion about it. Now, the identification of alternatives module is pretty much as it says. We want to define the universe of alternatives. it takes a very broad view of the universe of alternatives. So we're not just looking at chemical-to-chemical substitution. We want you to consider the use of alternative materials, product redesign, anything else that you can think of that might be pertinent manner for dealing with replacement of the toxic chemical. And I personally have had that problem where companies that I've dealt with have only looked at, well, this plastic won't accept this flame retardant as an alternative, therefore I should just eliminate it. But when you investigate it a little bit more, you find out that actually if you blended the plastic, it would take it, and that blended plastic would perform as well as the unblended plastic. So that's a relatively minor change that you can make to the process that would allow you to keep that alternative in for consideration. So you need to consider more than just a chemical-to-chemical substitution. Now, there are other modules that I'm not going to go into, and I'll go into a bit now some of the assessment modules. Again, I won't go through all 7, but I'll give you an idea of how we approach it. So the performance module is based on work, and we did this a lot for all of the modules, and I think that was important for including it in here. We tried not to reinvent the wheel as much as possible, but we tried to go out to all the other guidance that was out there and pull concepts and ideas into our guidance so that we can, be both as comprehensive as possible, but also to make sure that we're including work that is done by other people that have experience in the field as well. So we used information from the Toxic Use Reduction Institute at the University of Massachusetts Lowell, and then also I mentioned the guidance from the European Chemical Agency, and there's lots of other information that we use that's not really represented in that as well. We wanted to provide ranges for simple qualitative, well, each module has a certain number of levels. The levels vary anywhere from 2 to 5 levels, and basically each level has sort of increasing requirements and increasing expectations. So level 1 might be a very, qualitative thought process consideration, and then it moves up the level, requiring increasingly more detail and more qualitative information as you move up the ranking. The performance module consists of 3 levels, as I said, with increasing complexity and data requirements. Here's an example of the 3 levels. As I mentioned, level 1 is a qualitative information or assessment based on really readily available information from manufacturers and other sources. Level 2 is a more quantitative with data reviewed by technical experts. And level 3 is, again, a quantitative, but also includes specific testing requirements that have been reviewed and validated by technical experts. So as you see, the requirements increase as you move up the levels, and that's pretty much standard for most of the modules. Now, the hazard assessment module is one that is of course, very important to the whole process. And the objective was to determine what hazards exist for potential alternatives to the chemical of concern. And of course, you also need to do the chemical of concern to make sure that you have something to compare it against, so that you do the chemical of concern to establish the baseline, and then you compare the alternatives to that baseline. Now, it's really based on methodology that was developed by EPA's Design for the Environment Safer Product Initiative and their alternative assessment program. So they've developed a number of 18 criteria that they evaluate. Not everybody has the resources of EPA, though, however, so that what happened with Clean Production Action took that methodology, made it a little bit easier to implement and also to deal with things like data gaps, because EPA has the resources that they can fill in most of the data gaps that might show up. But if you're a smaller company with limited expertise and resources, you may not have that expertise. So how do you deal with data gaps? So Clean Production Action basically took the methodology and made it more usable, if you will. The hazard assessment module also does include the ability to pre-screen using other simpler tools. So it's sort of like a screening methodology. And one of the advantages of having a screening methodology is it allows you to eliminate chemicals that are clearly not viable or less favorable as an alternative. So if you're dealing with a chemical that has, is carcinogenic or mutagenic or has some of the major human health criteria, you don't want to replace it with another chemical that's also carcinogenic or mutagenic or whatever. So you can do those cross comparisons, and if you find potential alternatives are, carcinogenic or mutagenic, you can just say, I'm going to put them in this less favorable bin, and I'm going to concentrate my limited resources on the alternatives that don't have those problems. The hazard module does include 3 screening options, and I'm not going to go into detail. The first one is basically a list translator where they compare it against a list of authoritative bodies, people like Proposition 65 in California, or the International Agency for Research on Cancer, or the National Toxicology Program. They have established lists of chemicals that are, carcinogenic or reproductive toxin, or Washington State has a PBT list, and so does EPA. There's lots of authoritative lists out there, and basically what a list translator does is say, okay, is your alternative, does it appear on any of those authoritative lists? If it does, then maybe that's one I'll put into the less favorable bin and concentrate my resources on the ones that don't appear on those lists. The level 2, we call a list translator plus because it adds more lists for comparison. They're probably not as authoritative as the ones used in the first level, but they still give a good indication. And then the third one is something that Washington State has developed. It's called the Quick Chemical Assessment Tool. And basically what it does, it narrow focuses down on not the full 18, but 9 criteria that we think are the highest priority. It's not saying the other 9 aren't important, but these are the ones that are really most important. And it looks at a lot of more data sources for those 9 criteria. More databases, more risk assessments. So you do a deeper dive than what you do just at looking at individual lists. So the objective of the QCAT though was, we wanted to really see if we could eliminate ones from consideration. So again, QCAT, like any screening methodology, is very good at telling you which chemicals are a problem. What it's not very good at is telling you which ones are good. So don't think of QCAT as the end necessarily. It's a place to start to weed out the problems and then maybe go a bit further. It does penalize for lack of data, and it does something that's somewhat different, and I'll mention it in the next slide. I wanted to make sure that the QCAT results were very clearly different from the green screen, so I use a different methodology for ranking the QCAT chemicals. And I wanted to let it know, too, that there's a greater risk that you're making a bad decision, because as I said, QCAT is really good at telling bad chemicals, but even if you get a good grade in QCAT, since it's not as comprehensive as a green screen, you can't really be sure that it's as positive as a QCAT might indicate unless you do that deeper dive. One objective, though, of a QCAT, though, was to try to make some processes a little bit easier for companies with fewer resources and less expertise. So smaller companies, it was really geared towards smaller and medium businesses that don't have the expertise of an EPA or a Hewlett-Packard or some of the other companies that are involved in it. And this is how I differentiated. The table on the right, the colors on the right are the results of a green screen assessment. So green screen identifies chemicals in 4 benchmarks with chemical to avoid being given a benchmark 1, and then chemicals that are preferable are benchmark 4. In QCAT, we give them grades, so that a chemical that has a grade F, and everybody can identify, if you get a grade F, you know what that means. That means bad news. So it's the same for the screening results. If you get an F, it's a chemical that you should set aside and concentrate on the others. Like the green screen, the QCAT does also show the results in a matrix form. So it's very easy to identify the differences between a chemical. So here's an example of 2 groups of chemicals, some chlorinated and fluorinated compounds. The ones in gray, by the way, with a strike through are the criteria that QCAT does not look at. But we're using exactly the same table as the green screen table, so you can see the comparison between the 2. But what we do in QCAT is that we do give a negative mark or negative connotation if it's missing some important data gaps. So if you do an initial evaluation based on what data is available, you'll see that the fluorinated compounds look like they're low for most of the important criteria, And just looking at it, there's equivalent in terms of persistence, but just because a chemical is persistent, that does not necessarily mean it's an issue. But what happens if you look at data gaps, you'll see that the fluorinated compounds had no data on ecological toxicity. So the initial grade it received was a B, but once you look at the data gaps and how important the data gaps were, it was reduced to an F with parentheses DG, which means that the F was assigned because of data gaps, so that a company could revisit it if it was able to find the information and fill in that data gap or those data gaps and reassess the chemical. But if a chemical gets an F without data gap, it pretty much means that problems have been identified. So it differentiates between an F and an FDG. So I do want to go into the hazard assessment module. I have only 5 minutes left, so I might go a little bit more quickly from here on, and I apologize for that. But the hazard module does have 2 levels. The level 1 is the green screen, and the level 2 is what we call the green screen plus. And basically, it's something. Green screen plus is more similar to what EPA does, where it fills in the data gaps using computer modeling or scientific studies, and then it also has the results validated by qualified scientists. The exposure module, I do want to go into it quickly as well, was based on information from the National Institute of Occupational Safety and Health. And it requires, this is the one that has 5 ranges from simple exposure evaluation to a full-blown risk assessment. It is expected to be used after the hazard evaluation, as I mentioned in the risk reduction process, and will assist in narrowing down alternatives. Excuse me, I should have warned you that I'm coming down with a cold, so my voice is getting a little rough, and I apologize for that. Actually, it says 4 levels, but I think it's 5 levels in the final result, so that might be an error in the slide. But one of the reasons that we think exposure is important, if you have a number of chemicals that have very similar hazard concerns, so in other words, if you have 5 chemicals, say, that have very few hazard concerns, what you need to then do is to try to differentiate between them and say, okay, out of those 5 that don't have any hazard concerns, are there other issues? And that's where many of the other modules come in important. Are there life cycle concerns that make one of those 5 less favorable than the other, or are there exposure concerns that would make one of those 5 less favorable? So it's very important to keep that in mind, that it's sort of winnowing down by looking at all of these criteria, including exposure. It says 4, but I swear, and I must be remembering correctly, I thought the exposure module had 5, but we'll go with it and pretend that it has 4, but don't be surprised if 5 show up in the final document. So again, it starts with a fairly qualitative approach and then ends up with a full risk assessment. So the schedule, and this is where you have news hot off the presses. There are no remaining module outlines. The last module was released last week, and you can find it on our website. We are working towards the end of the draft guidance. It says end of 2012. Boy, is that out of date. What happened at a meeting of the guidance team this morning is that we have authorized the release of the guidance document for a 45-day public comment period. I'm working with the Interstate Chemicals Clearinghouse to get the document posted, but I hope to have it posted as early as maybe even next week. And then once that's out, it'll be out there for the full document with all of its gory detail. And we do have information on some websites, and I think it's coming up. Yes, here's the information on the websites. We do have a website that Ecology has set up that has all of the modules, all of the public comments we've received to date, all of the workshops we've conducted, as well as recordings of those workshops and pre-copies of the presentations, the 2 webinars that we had, including recordings of the webinars. So that's where you can hear 3 hours plus of me talking about the guidance. We also have a blog that you can access and see some information and provide input on the guidance as well. The process that we ran was that, as modules got released, we posted them and invited people to provide input. So it's very important to know, though, that what modules might appear on the Ecology website will look different in the draft document, because we actually took a lot of those comments and input and made changes to the document along the way. So the modules that were posted as they were created have gone through an editing process and will look slightly different in the draft document, because we do want to include stakeholder comments as much as possible. I do want to make one other point on this slide a couple of points on the slide that's important. Because California is the only one that has authority to require an alternative assessment, the other states will be doing it solely on a voluntary basis. We do have funding, though, to go out and actually test the guidance so that once it's completed, I hope to be able to go out and test it in real-life situations and see if it does what it needs to do. We'll be using contractors for that. So, but the end result will be that we hope to have the guidance document completed, including a response to comment document, by June 30th. And that date is fairly solid because that's the date I lose all of my contractors. So we're pretty sure that we'll have the final document done by then. It will be posted, as I mentioned, on the hopefully on the IC2 website. And I think I've copied those other points. So that's pretty much all. I just made the deadline. If you have any comments or questions, or feel free to give me a call or send me an email, or my boss, Ken Zarker, which I think probably a lot of you know as well. So thank you very much for your time and for listening so patiently, and we'll throw it open for questions now.
Thank you so much, Alex. Well, I have a number of questions and comments. I did send you one through the little message box, so if you want to check that out from about the state of Maine also, so you can pop that in. But we have a comment that another important point about risk assessment is that it is usually based on single exposure and does not account for synergistic effects with exposure to other toxic and hazardous substance. Another reason that exposure determinants should be considered as very conservative, not even average. So that was just a comment that somebody had sent in. But we do have a question with regard to the comment about increasing childhood diseases. And do you have a particular source for that comment?
Right. I do have some slides that I've used in previous presentations, and I can provide those. I don't know them off the top of my head, but yeah, there are a number of, and actually one comment I was going to make, I was at a Global Chem meeting yesterday, and Global Chem is where it's a conference that is held by a lot of the chemical manufacturers, and the American Chemistry Council is one of the sponsors. So the opening speech was by Cal Dooley, the president of ACC, and they had a scientist from McGill University as the keynote speaker. He said at the Global Chem meeting yesterday that there are increases in some childhood diseases like autism, childhood cancer, brain cancer in particular was mentioned. So yes, I can provide that information. I do also want to comment that, you know, it was noted that Maine also has the authority to require an alternative assessment, and it was not that I was trying to leave Maine out, but Maine is not a member of the guidance team. So of the guidance team members, only California had the authority, but Maine does have you can go to the Maine website and they have posted alternative assessments that they have received on some of the chemicals that they've required companies to evaluate.
Great, thank you. I thought that Massachusetts, under their TURA, under their Toxic Use Reduction Act, also required alternative assessments, but I'm not sure about that.
No, I'm pretty sure they don't.
Okay.
So anyway.
So we have a question here. Mr. Stone, the National Academy of Science has this recommendation in its Green Book, Report to EPA on Sustainability. It's point 5.1. Key recommendation, EPA should include risk assessment as a tool when appropriate as a key input into its sustainability decision, quote. I never interpreted the Academy as wavering on its support for risk assessment. Are you saying that they are? Thank you for your reply.
I have not. I don't want to speak for the National Academy of Sciences. I think what the point that I was trying to make was that they think that risk assessment is not enough, and that's what I read as 4.6 to say is that, you know, risk assessment they've been using, and you know, risk assessment is a tool, and I'm not trying to knock say risk assessment does not have its uses and its applications, but you know, we've been doing risk assessments for decades now, and we still have issues with chemicals getting out into the environment, toxic chemicals being used. I've read plenty of risk assessments that, I can go in excruciating detail on the flame retardant decabromo diphenyl ether. Risk assessments are very much dependent on the assumptions that you have made. And exposure is primarily based on assumptions, and you try to quantify those assumptions. Hazard assessment is not based on assumptions. It's based on scientific criteria. Now there is some, some identification of the ranges, and there is individual input into that process as well. So I think risk assessment does have its role to play, and I think it helps in terms of prioritizing chemicals for concern as well. But in terms of dealing with and replacing toxic chemicals, the objective of an alternative assessment is not to assess whether or not a chemical causes a risk through exposure. Its objective is to eliminate the use of the toxic chemical, because if you don't use the toxic chemical, exposure becomes moot to some extent, particularly if you reach the green chemistry goal of reaching a chemical or finding a chemical that has minimal impact on human health and the environment. And before somebody brings it up, yes, I know water is toxic, but if we get to, or water can kill you, I guess, to some extent, but if we get to the point where all I need to do is to apply a no swimming placard on a tank of chemicals, I think we can declare success.
Okay, thank you. And we have another question. Is the QCAT procedure being used by the state of Washington on a set of chemicals or by any other agencies or firms yet?
We have been using the QCAT on some of our pollution prevention, our voluntary work. So we have done assessments and provided that information for our staff. One thing that I hope to get to, we have not been using it a lot in terms of, because the intent of QCAT is not for Ecology to use it and give the information to companies. The objective of QCAT is to have companies use it and being able to do it themselves. Because of the working on the guidance, I have not been able to, sort of go out and find sponsors to do that. And I hope to do that as soon as the guidance is complete, is to actually go out and field test it. There are people who are using QCAT, and QCAT was used in a number of ways that I did not expect. So Hewlett-Packard, for example, uses it as a screen for its alternative assessment, so that before it subjects alternatives to a green screen assessment, it will run it through the QCAT assessment and decide whether or not there are any known issues that eliminate it and move on. It's also been used by groups like the Green Chemistry and Commerce Council. They did an alternative assessment on phthalate, and they used the QCAT to narrow focus. I think they had 10 alternatives, and they did a QCAT evaluation and reduced it down to 4 that they then did a full green screen assessment on. So yes, it has been used in ways that I had not expected, but I still would like it to be, it was developed as a tool for small businesses, so I still need to go out and spend more time working on that aspect of it.
Okay. In what, this is for Alex, in what context do you expect the member states that do not have mandated alternatives assessments to use this alternatives assessment methodology?
I think what, I know I can speak from Washington, so I think what we expect to do, this guidance is very broad because we're dealing with different states and different directives. California, for example, in their legislation, it specifically requires them to include life cycle thinking in their alternative assessment. So quite often different states have varying interests and priorities and things like that. So what Washington expects to do is to go to the guidance and say, okay, we think that you should do this is the minimum that we think is acceptable for an alternative assessment. So to set sort of the minimal bar using pieces of the guidance. It's not expected that any organization would encompass the whole guidance and require people to do all different types of assessments. The intent behind the guidance was to be sort of flexible and because there are not one alternative assessment will meet all products or processes under evaluation. So the intent is to have it sort of broad and being able to fine-tune it for a particular process. But I think the states might go in and say, okay, this is the framework, this is the way we think you should do and alternative assessment. These are the modules we think you should use as a minimum, and this is the order that we think you should implement those modules, and maybe even what levels within the modules you should use. So they can go and pull from it and create sort of the minimum expectations. And I think that's where primarily the states will be using the guidance.
Great, thank you. And I have another question. Can you suggest specific tools and resources that you find especially useful to help predict toxic effects when data gaps exist?
We do include some of that information. I did not mention it during the presentation, but we do have an appendices for most of the modules where we do talk about tools and resources and information to do that. I think, though, that it's pretty clear we're always going to have to deal with data gaps, at least until maybe REACH becomes more commonly implemented, and at least for our hazard assessments, we did try to. The green screen has been adapted or updated to coincide with European Union REACH and GHS expectations. So once those laws come into more broad effect, I think we'll have fewer data gaps to deal with. But yes, there is information. There are, for example, examples of tools that can be used for QSAR, quality structure activity relationships. And one thing that pops to my mind is that the Danish EPA has a database of something like 60,000 chemicals where they have done computer modeling, and then they post that information and it's available for free. So resources like that will be identified in the guidance as well.
Thank you. I think that's all the questions, and we're certainly bumping right up against 3 o'clock my time, 4 o'clock Eastern time. We really want to thank you, Alex. That was really interesting, and I really encourage people to go to the website and check out the modules. I think this is a very, very useful tool, and we will have all the information about it on our respective websites. In the near future, we'll be posting the PDF file, and also, as Clinton said, within the next week or so, the actual recording of the webinar with the PDF, so visually, and you can hear it as you watch the slides. Again, next month we have Dennis McGavis from Goodyear Tire, which I think is going to be very interesting. We've been hoping to have a presenter from heavy industry, and it should be a different take on green chemistry and efforts towards that than we've had in the past. So I hope that we'll hear from you again next time. I hope that you'll spread the word to your colleagues about these webinars, and please visit our websites, and thank you again. Good afternoon.
Thank you.